In this lesson, you'll learn how to multiply and divide monomials and use expressions written in scientific notation. Why is scientific notation useful in economics? Economists often deal with very large numbers. For example, the table shows the U.S. public debt for several years in the last century. Such numbers, written in standard notation, are difficult to work with because they contain so many digits. Scientific notation uses powers of 10 to make very large or very small numbers more manageable. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. Monomials cannot contain variables in the denominator, variables with exponents that are negative, because that would be like in the denominator, or variables under radicals. So we have examples of monomials and non-monomials. Constants are monomials that contain no variables, like 23 or -1. Constant means it can't change. The numerical factor of a monomial is the coefficient of the variable. For example, the coefficient of m in -6m is -6. The degree of a monomial is the sum of the exponents of its variables. For example, the degree of 12, g to the 7th, h to the 4th, is 7 plus 4, which is 11. The degree of a constant is 0, because there's no variable. A power is an expression in the form x to the n. The word power is also used to refer to the exponent itself. Negative exponents are a way of expressing the multiplicative inverse of a number. For example, 1 over x squared can be written as x to the -2. Note that an expression such as x to the -2 is not a monomial. Can you figure out why? For any real number where a does not equal 0 and any integer n, a to the -n equals 1 over a to the n, and 1 over a to the -n equals a to the n. So 2 to the -3 is the same as 1 over 2 cubed, and 1 over b to the -8 is b to the 8th. To simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. That -2 times a cubed would be 3 factors of a times -5a, and then I've got 4 factors of b. So altogether, negative times negative is positive, and I've got a total of 4 factors of a and 5 factors of b. That suggests the following property of exponents. For any real number a and integers m and n, a to the m times a to the n is the same as a to the m plus n. So power times a power, we add exponents. So with numbers, if we have 4 squared times 4 to the 9th, we get 4 to the 11th, or b cubed times b to the 5th is b to the 8th. A similar rule is in place for division. If we have x to the 9th divided by x to the 5th, anything divided by itself is 1, even if they're x's, because x could represent any number. So I have x to the 4th left. So power divided by a power, we subtract exponents. For any real number where a does not equal 0 and integers m and n, a to the m divided by a to the n is a to the m minus n. 5 cubed divided by 5 would be 5 to the 3 minus 1, or 5 squared. X to the 7th divided by x cubed is x to the 7 minus 3, or x to the 4th. Simplify, and division by 0 is not allowed, so they say assume that s cannot equal 0. Okay, power divided by power, we like to subtract exponents, and it's nice to subtract the bigger minus the smaller, so 10 minus 2, and we'll just have 1 left in the denominator. That's the shorter way that I try to teach you guys. You could have also done s to the 2 minus 10 is s to the -8th, but then to get your simplest version, you're going to have to do the reciprocal, because negative exponent means reciprocal. So to me, I go with this way, because it's faster. Power divided by power, we subtract exponents, so 4 minus 4 is x to the 0. I said before, anything divided by itself is 1. So 1 times 1 divided by 1 times 1 times 1 is 1. So we've just shown that x to the 0 is 1. Suppose a and b are real numbers and m and n are integers, and the following properties hold. Power of a power, we multiply exponents. Power of a product also kind of looks like multiplying exponents, kind of looks a little like distributive property. And power of a quotient kind of looks like distributive property as well. We're giving each part of the fraction the exponent. Power of a power, we multiply exponents, so 2 times 4 is 8. Negative 3 cubed, negative 3 times negative 3 is 9, times negative 3 is negative 27. And then power of a power, we multiply exponents, so c to the 6th, d to the 15th. Negative 2 to the 5th is negative 32. A is now to the 5th, and b, 2 times 5 is 10. Negative exponent means reciprocal, so this would be the same as 3 over x to the 4th. 3 to the 4th is 81 over x to the 4th. So negative exponent is reciprocal. It doesn't change the sign of our number. Negative 3 to the 5th is negative 243. Power of a power, we multiply exponents, so it's going to be a to the 25y over a to the 30y, b to the 20. A monomial expression is in simplified form when there are no powers of powers, each base appears exactly once, all fractions are in simplest form, and there are no negative exponents. The form that you usually write numbers in is standard notation. A number is in scientific notation when it is in the form a times 10 to the n, where a is between 1 and 10, and n is an integer. Scientific notation is used to express very large or very small numbers. Scientific notation always has exactly one digit in front of the decimal, and I can count 6 places to get to that, and we're in scientific notation. I still want exactly one digit in front of the decimal. This time I need to count, there's 2, 4, 5 places to get to where the decimal is. So it was a small number, so I'd have to move it. I moved my decimal to the right, so to put it back in standard form I'd have to move it to the left, so I need 9.2 times 10 to the negative 5th. Evaluate the product, express the result in scientific notation. 5 times 7 is 35. Power times a power, we add exponents, so it would be 10 to the 11th. But in scientific notation, we're only supposed to have one digit in front of the decimal. So 35 I could rewrite as 3.5 times 10 to the 1. Power times a power, we add exponents, so my final answer is going to be 3.5 times 10 to the 12th. 1.8 times 4 is 7.2, times 10 to the negative 4 plus 7 is 3, and we're done. Real-world problems often involve units of measure. Performing operations with units is known as dimensional analysis. There are about 5 times 10 to the 6 red blood cells in 1 milliliter of blood. A certain blood sample contains 8.32 times 10 to the 6 red blood cells. About how many milliliters of blood are in the sample? Okay, I know I have 8.32 times 10 to the 6 red blood cells, and I want to find out how many milliliters there are. So in the first sentence, they said there were 5 times 10 to the 6, I'm going to abbreviate it, red blood cells. Not a real abbreviation, just made that up. In 1 milliliter of blood. So my red blood cells will cancel out because anything divided by itself is 1. I'm going to end up with the units milliliters that I want. So denominator means divide. So I'm going to take 8.32 times 10 to the 6. Oh, my 10 to the 6 will cancel out when I divide by 5 times 10 to the 6. So all I really need to type in the calculator is 8.32 divided by 5, and I get about 1.66 milliliters. Okay, we did all of these topics probably over an entire chapter in Algebra 1 that we just summarized in one lesson. We have negative exponent means reciprocal, power times power, add exponents, power divided by power, subtract, power of a power, multiply, power of a product or a quotient, raised to the same power, and scientific notation can be used to represent very large or very small numbers.